Welcome to Homework Lib.
So here we have two boxes of fruit that is connected by a light string as indicated here. So let's say these two boxes have the masses. Let's say this is M1 and this is M2. So M1 is given out to be 10 kg and M2 as 20 kg. And a force of 50 Newton is applied to the right box here. So we need to figure out the acceleration of each block and the tension in the string. So in this case, if we observe the free body diagram, we can figure out first the acceleration by considering this net force of 50 newtons and the total mass as m1 plus m2, that would be 30 kg. So this will give us acceleration as the net force over mass using Newton's second law. So we get the acceleration as 5 by 3 meters per second squared. So if we want to figure out the tension, we need to see the free body diagram of either of the object. So let's say we consider for M2, there is a force of 50 newtons to the right, there will be tension, and this is being accelerated at 5 by 3 meters per second square. So since it's accelerated to the right, the net force would be 50 minus t, and that will be mass times acceleration. So its mass is 20 and acceleration is 5 by 3. So this would give us the value of t as 50 minus 100 over 3. So that will be 50 by 3 newtons. So yes, we have figured out the acceleration as 5 by 3 meters per second square and the tension as 50 by 3 newtons. Now the complete setup, we have to repeat this complete thing by considering the kinetic friction between each block and the surface to be 0.1. So if we have the kinetic friction here, let us draw the free body diagram of, let's say, this M1. So there is tension and it will accelerate with acceleration a, and there is friction force that will act to the left, that will be mu times r, and the value of mu here is given as 0.1. So reaction will be just its weight because it will be ballast and its weight is m1g. So we have the value of m1 as 10. So considering g as 10, we get the friction force as zero point 0.1 times 10 times 10. So this comes out to be 10 newtons. Another block, if we see M2, so here the tension will be to the left and it is accelerating with acceleration a because the force of 50 Newton is applied, and there is the friction force which will be mu times m times g. So this would be giving us the free body diagram of the two objects separately here. So we apply Newton's second law. So the net force here in this block M1, that will be T minus 10 is equal to m1 times a. The mass is 10, so 10 times a. That's equation 1. Similarly, applying Newton's second law to this block m2, we get 50 minus t minus zero point 0.1 times 20 times 10, that will be 20, and this is equal to m2 times a, so 20a. This is equation 2. So we just solve these two equations to get the values of t and a. So we can add them first. So we get, so first we simplify this equation 2. We get 30 minus t is equal to 20a. So let us add these two equations. So we get 20 is equal to 30a. So still in this case, we are going to get the acceleration as 2 by 3 meters per second square. And we put this value of acceleration in either of these equations. So let's say I put in equation 1. So we get t minus 10 is equal to 10 times a, that is 2 by 3. So this gives us t as 10 plus 20 by 3. So that will be 50 by 3 newtons. So in the second case as well, we get the tension force as 50 by 3 newtons.